Hi guys, welcome back to our discussion on infinite series. So in this video, now we will discuss about geometric series. So by definition, when you say geometric series, it is a series of this form, a summation of AR to the n, where n is from 0 to infinity. If the value of n is 0, then you have AR to the 0 or A, plus if n is 1, then you have AR to the 1 or AR, plus if n is 2, then you have AR to the second power, and so on and so forth. Now, provided that the value of A is not equal to 0. But how do we determine whether the given geometric series is convergent? So according to this theorem, a geometric series with ratio r diverge when the absolute value of r is greater than or equal to 1. But if the absolute value of r is less than 1, then the series converge to this sum, a over 1 minus r, provided that the absolute value of r is less than 1. Okay, so given, for example, the series summation of 3 over 2 to the n, where n is from 0 to infinity. And since we don't know yet whether this is a geometric series, so we have to rewrite this in the standard form. But what is the standard form? The standard form is summation of a r to the n, where a is constant. And because 3 is constant, you can factor this out. So you can write 3 over 2 to the n as 3 times 1 half raised to the n power. Wherein, if n is 0, 1 half raised to 0 is 1 times 3. So 3 times 1 is the first term. If n is 1, then you have 3 times 1 half raised to 1 is 3 times 1 half as the second term. Plus, if n is 2, then you have 3 times 1 half to the second power as the third term of the series. So, because this is now in the form of summation of a r to the n power, where n is from 0 to infinity, so we can now define a here as 3 and r, which is the ratio, as 1 half. And as you can see, because the value of r is less than 1, so we can therefore conclude, based on theorem, that the series converge. And the sum of this series is, from the formula, is a over 1 minus r, where a is 3 and r is 1 half. But 1 minus 1 half is 1 half, and 3 over 1 half is 6. So therefore, the sum of this geometric series is 6. And as you can see in this illustration, the graph of the function 3 times 1 half raised to x approaches this value, which is 6. So therefore, the sum of the series is 6. And the limits of the function is also 6, which is the sum of the geometric series. Okay, another example. Suppose you're given the series summation of 3 over 2 to the n power, where n is from 0 to infinity. If the value of n is 0, then you have 3 over 2 raised to 0 is 1. That's the first term of the series. If n is 1, then you have 3 over 2 to the 1, or 3 over 2. If n is 2, then you have 3 over 2 to the second power. That's 9 over 4, or 3 over 2 quantity squared. Plus, if n is 3, then you have 3 over 2 to the third, or 27 over 8. So, in this case, as you can see, the value of r here is 3 halves. And because 3 over 2 is greater than 1, so we can therefore conclude that this geometric series is divergent, or the series diverge. Okay, in this slide, this given series, a summation of, so this is summation of 1 over 2 to the n power. Okay, if you look at this series, this is not yet in standard form of the geometric series. The standard form should be AR to the n power. So to do that, we expand this first, that if n is equal to 1, then you get 1 half, plus if n is 2, you get 1/4, plus if n is 3, then you have 1/8 and so on and so forth. So because 1/2 is common, so you can factor this out. So you have 1/2 times 1 plus, since we factor out 1/2 from 1/4, so this is 1/2. Factoring out 1/2 from 1/8, so we get 1/4, and so on and so forth. Or you can write this as a summation of, or 1/2 times. This can now be written as the summation of 1/2 raised to n, no, as where n is from 0 to infinity. So to check if the value of n is 0, so you have 1/2 raised to 0 is 1. If n is 1, then you have 1/2 raised to 1 is 1/2. And if n is 2, then you have 1/2 raised to the second power is 1/4. So this summation can be written in summation notation form as summation of 1/2 raised to n, where n is from 0 to infinity. And because this is constant, you can bring it here inside the summation notation. So you can write this as summation of 1/2 times 1/2 raised to n, where n is from 0 to infinity. So you can now, this is now of the form summation of AR to the n power, where the value of A here is 1/2 and the value of R is 1/2. And because the absolute value of R is less than 1, we can therefore conclude that the series converge. But what is the value of convergence? Recall that the value of convergence, or the sum of the geometric series, is defined as A over 1 minus R. So if A is 1/2 and R is also 1/2, so 1/2 over 1 minus 1/2. But again, 1 minus 1/2 is 1/2. So this is 1/2 divided by 1/2 is equal to 1. So this is the sum of the geometric series. Okay, so in summary, what we have learned in this lesson are as follows. We define that a geometric series is a series of this form, summation of AR to the n, where n is from 0 to infinity. That if the value of n is 0, you have A. If n is equal to 1, then you have AR raised to 1, or AR. Plus, if n is 1, then you have AR squared, and so on and so forth. Provided that A and R are not equal to 0. And to determine whether the given geometric series converge, we have to check whether the absolute value of R is less than 1. If it is less than 1, then the series converge to this sum, A over 1 minus R. Otherwise, the series diverge. Also, if you're given two convergent series, summation of A sub n and summation of B sub n, and if A, B, and C are real numbers, such that summation of A sub n is A and summation of B sub n is B, then the following series converge to the indicated sum. Summation of C times A n, where n is from 1 to infinity, is C times A. Summation of the sum A sub n plus B sub n, where n is from 1 to infinity, is A plus B. And the third, summation of the difference A sub n minus B sub n, where n is from 1 to infinity, is equal to A minus B.